Okay, next we're gonna take overview. We're gonna take an overview to all of those, let's say, components of securing a network. So at the identity management part is a part of network security. Then we're gonna go to the content security and application. Then we're gonna go to the IPS, and then to endpoint security. So as I said before, identity management is very important because you have to control each asset connected to the network to authenticate it, and also authorize it so that it doesn't have full network access but only restricted access as it needs. So the challenge is that not only everything has to be authenticated and authorized, like mobiles, tablets, laptops, computers, printers, phones, whatever, but also ideally we would want to control everything from a single point, a centralized point to configure all of those policies, how devices are authenticated and authorized when they are connected to the network. And Cisco has a solution for that. It's called the Cisco ISE, or Identity Services Engine. And this is the core of Cisco security architecture, because as we're going to see in the end, because ISE controls how devices are authenticated when they're connected to the network, and then what access they are being allowed, what are the devices being allowed to do in the network. Then this is the core of Cisco security architecture, because if this solution manages network access, then if, for example, if an endpoint got attacked and it's infected, then we would want ISE to change authorization of that device. So we're going to isolate that device to be able to do remediation and contain the attack. So if we have one solution, which is ISE, which controls initial network access, then the same solution should restrict network access when a device has been infected, and we have been, of course, we have been notified about that infection, of course, via other security tools implemented in the network. So that's why it's the core of Cisco's security architecture. It's also known as NGN Radius, because we're going to see in a couple it does much. It's in the end, it's a radius engine, but an evolved radius engine with a lot of capabilities back and forth. So it offers centralized secure network access control, who can connect to the network, how is it authenticated, and what is its network access. And also because in a network we have not only our employees connected, and also non-user devices like printers and for example IP phones, we also have guests connected to the network. It makes sense that ISE needs to be able to also support guest services and BYOD. I'm going to speak about BYOD a bit later. Bring your own device. Also, in order to be able to restrict network access on a connected device to the network once it has been infected, it means that ISE has to be able to communicate with other security systems, which those security systems which are going to monitor the network and detect when an endpoint got infected, then those solutions are going to tell ISE, hey, we have this endpoint which got infected, instantly cut network access for that endpoint, and so that we contain the attack and we can perform remediation afterwards. And also we're going to see that ISE is able to logically segment the network via TrustSec. We're going to see what TrustSec is. It stands for Trusted Security. So ISE is going to, the main challenge nowadays is, as you're going to see, that okay, we want to authenticate devices and control what devices can do in the network, but it's no longer enough to let's say make that control happen just based on the username, or based on the device type, or based on the IP address of the user. Nowadays we want this technology, which is ISE, when it authenticates devices and allows them access to the network, we would want ISE to give different types of access to the network based on the context of that user. So what that means is that ISE is going to be able to let's say to authorize differently a connected device, so what that device can do in the network, based on, first of all, who is the user or the device. Is that a user, is that an employee, or is that a third party user? Is that a company owned device, or is it a untrusted device, like again from a third party company that we do business to business, and they also need access to our network? From what device did it access the network? So did the user come in from a VPN connection, from a Wi-Fi connection, or from a wired connection? That's going to be also from where did the user access the network. From what device, it means like, was that a mobile phone, was that a tablet, was that a laptop, was that a regular desktop? Because, for example, depending if the user accesses the network via a mobile, not via its laptop, it makes sense that we're going to give to that user different access, because a mobile has limited capabilities on which applications it supports natively, so that clearly that user is gonna need different access from a mobile phone as opposed to a computer or a laptop. When did the user access the network? Because, for example, you can imagine that in general, users are accessing the network at pretty much, let's say, regular hours. Like, for example, if I sees that a VPN connection came in and it has to, of course, authenticate and authorize that VPN user, then, for example, how many times do you see somebody from the, let's say, finance department connecting via VPN at 3 a.m. in the morning? Not that often, right? I mean, the engineers usually connect to the network at 3 a.m. to fix a problem, but from the people from the finance department or from the legal department, very rarely they connect to the VPN at 3 a.m. in the morning. So that may be a big question mark, like, what is this user from the legal department coming in a network via VPN at 3 a.m.? So based on the hours of the connection, we may want to give to the same user different authorizations in the network. How did the user access the network? As I stated, via VPN, Wi-Fi, or wired. And what is the health status of the user system? So we need a way to somehow inspect that device to see if it's infected or not, to see if it has an antivirus installed or not, to see if it has which operating system version, if it has the patches installed or not, because we want to give different access to the network based on the health state of that device. Or if the device is clearly infected, then we want to give no access to the network, because if we give an infected endpoint access to the network, it means that endpoint can infect other endpoints. So this is what a context means. We want ICE to give different type of accesses to authorize differently, maybe the same user, depending on from which device the user connects, at what time that does user connect. How does the user connect? From the VPN, from a Wi-Fi, or from wireless? And is the health state of that user's device, is that device healthy? Is it compliant with our enterprise policies? And based on that context, that set of attributes, we're going to give to the user different access to the network. So the first step is here going to be the authentication part. So to authenticate devices connected to the network. And of course, once you implement this technology, it means that you have to authenticate and control all connected devices to the network. All of them have to be authenticated. And for that, we have a couple of options to authenticate all devices connected to the network. We can authenticate devices via 802.1x, which is also nothing else but EAP in the end, extensible authentication protocol. We're gonna in general perform 802.1x authentication for internal users' systems, for our own assets, which are belonging to the company, to the enterprise. Or we're going to authenticate those devices via MAB or profiling for systems not supporting 802.1x. In general, those are going to be like non-user systems, like old printers or old IP phones or old video conference systems. Or in the case of authenticating the guests, then we have to authenticate them via the guest web portal. So based on, we have different methods to authenticate users based on the type of the user. Is that an internal, an employee device and user? Also, does that device support .1x or not? Or is that user a guest? Now let's look at .1x authentication part, which ideally in general you're going to use .1x for as many connected devices as you can, because it's the most secure, let's say, option. So .1x components are going to be, we're going to have something which is called the supplicant, or the supplicant is going to be a software on the end user system which is going to be used and configured to perform EP authentication. You can either use the built-in supplicant in the operating system, which all modern systems have that, Windows, Linux, and Mac, or you can use another software which is going to be like, for example, the AnyConnect, which has a module to perform .1x authentication. So that's the supplicant. The supplicant is nothing else but the software which is going to present the authentication credentials to the network to get authenticated. The authenticator is going to be the device which is going to control network access. So the authenticator is where is that user connected to. So it's going to be a VPN gateway, the authenticator, a layer 2 switch, or a wireless LAN controller, because that's the three methods that you can connect any device to a network: via VPN tunnel, via wired infrastructure, or via the wireless infrastructure. So based on the connection type of the user, the authenticator is going to be the VPN gateway, the connected switch, or the wireless LAN controller, or the access point by itself in case you don't have centralized Wi-Fi. And in the end, it's going to be the authentication server, which is going to be nothing else but Cisco ISE, which is going to be the device which is going to receive the credentials from the user and validate those and grant, let's say, specific authorizations to control what that user can access in the network. Now, if you look at the Cisco document in here, which is a chapter 8.1 security summary, I'm going to make use of this just to show you, to visually to show you those components. So we have the supplicant. This is a Wi-Fi connection, but it's the same process for all types of connections, VPN, Wi-Fi, or .1x. So the supplicant is the device who wants network access. So it's going to be a computer or a mobile device or a laptop with a built-in supplicant. Then the authenticator is going to be either the access point or the wireless LAN controller for a Wi-Fi connection. For VPN, it's going to be the VPN gateway. For wired, it's going to be the layer 2 switch where the user is connected to. And the authentication server, which is going to be the radio server, in our case, is going to be the ISE server. So what happens, fundamentally speaking, the supplicant is going to present its credentials to the authenticator. So the supplicant presents its credentials to the authenticator. Then the authenticator sends those over to the radio server. The radio server, if the credentials are valid and are correct, based on, and also based on the context of the user, so who's the user, what's the type of the connection, from which device it got connected, and so on, it's going to return over to the authenticator a okay or not okay, which means was authentication successful or not. Let's say okay, it was successful. It is going to also return to the authenticator the authorization attributes. What kind of access do we allow to this user in the network? So okay, and the authorization attributes. If the authentication server says user is successfully authenticated, then the authenticator is going to grant network access to the user. It's going to tell him, okay, authentication was okay. And now the user is successfully connected to the network. But now all traffic sent by that user in the network is going to be controlled by the authenticator, and is going to give him access only as instructed in the authentication process from the radio server. And like as you can see, what happens is that we have those three blocks in there: the supplicant, the authenticator and the authentication server. And from a protocol point of view, between the supplicant and the between the supplicant and the authenticator, they're gonna speak 802.1x. It's a layer 2 protocol, that's the language. So the supplicant is going to present its credentials for being authenticated to the authenticator via .1x, and then the authenticator is going to translate those credentials over to the ICE server via radius. So between the supplicant and the authenticator, we speak .1x. Between the authenticator and the authentication server, we speak radius. That's why they're trying to say in here where the .1x portion is and where the radius portion is. But in the end, what it means is nothing else but that between the supplicant and the authentication server, we have a EAP communication. Because EAP stands for Extensible Authentication Protocol, we're going to have a lot of options to authenticate the device as being connected to the network. So you're going to use .1x to authenticate all assets belonging to the company as long as they support .1x. For devices that don't support .1x, like all IP phones, all printers, any kind of old devices, we're going to do MAB and ideal also profiling to authenticate, to grant them network access. Now MAB stands for MAC Authentication Bypass, so it's not really a authentication method. What this means is that the authentication server is going to authenticate that device connected to the network based on the MAC address of the device. Now components and the authentication flow is the same as in .1x. So you still have the device which wants network access, but it's not going to have a supplicant, but it is the end system. We still have the authenticator, which is going to be the switch, the VPN, or the wireless LAN controller, and then we also have the authentication server, so the same components. The difference is that this time, because there's no supplicant on the system, we're going to authenticate the user, the device connected to the network, via its MAC address. And of course you can imagine this is not very secure, because the MAC address can be easily spoofed. Like for example, if we would allow this device network access, and we authenticated that device not through .1x but via MAB, then what can happen is that if this user goes off of the network, clearly an attacker can come in here, connect to the Wi-Fi or to the wire switch, and use the MAC address of the user, and he gets the same access as that user. He's going to basically spoof the MAC address of the user which got authenticated successfully before. So because MAB is not really a strong authentication method, we just let the user in the network based on the MAB, on its MAC address. And of course also because you can imagine that if you have, let's say, like hundreds or thousands of devices which don't support .1x, and you want to authenticate those devices via their MAC addresses, it's going to be difficult to populate those MAC addresses statically on the authentication server side. Because the authentication server has to, of course, have configured the MAC addresses of devices which are going to be authenticated via their MAC addresses. So for that reason, because MAC authentication is not really secure and is not scalable as well, we're going to combine MAB with what is called profiling. So what this means is that profiling is going to be nothing else but profiling or fingerprinting the end device. So profiling allows the following. When this device wants network access, the supplicant, not the supplicant, let's say this is a printer which doesn't have a .1x supplicant. So when we connect the printer to the network, and the MAC address is going to be sent over for authentication to the radius server. Then on the radius server on ICE, we can configure profiling. And what this means is that we're going to implement some tools in the network so that ICE is going to be able to know a lot of information about this connected device. Like, is that device a printer? If it's a printer, what kind of printer? Is it an HP printer? What model? Is it a Canon printer? What model? So let's say it's an HP printer in our case. Let's say it's an HP printer model 7000 series or whatever. Then if that's a printer, for example, so what is the type of that device? Printer? What is the vendor? HP? And what is the model? 71000. Which means if I'm going to configure ICE with a rule saying that if we have a printer connected to the network, if it's model HP 7100, then we're going to give to that printer, for example, we're going to give to that printer only specific access in the network. Whatever that is. Let's say we're going to allow that printer to send only IP traffic destined to 10.10.10, for example. But if that printer is a Canon printer, Canon, of type, whatever the model, let's say 300 series, then if we have that printer connected to the network, they're going to give that printer network access. We're going to let that printer access resources destined to 10.0.0.0/8, for example, right? So what this means is that ICE is gonna have some built-in tools, and also the network is gonna need those tools configured as well, so that ICE can actually profile what is the type of device connected to the network, so that instead of authorizing the connected devices just based on the MAC address, we authorize them based on the device type, the exact specific device type, which this is clearly more secure and better. Because now, for example, if an attacker comes in the network, if an attacker comes in here and he spoofs the MAC address of one printer, then his fingerprint via profiling is not going to be an HP printer or a Canon printer, which means that ICE is not going to let that user in the network. ICE will know that somebody tries to pretend that it's an HP printer or a Canon printer. So this is why MAP is going to be, in general, combined with profiling. We need a way to profile network devices so we control which devices get access to the network, not which MAC addresses get access to the network. And of course, the last part is going to be the authentication for guests in BIOD. So for visitors, ICE has a built-in customizable web portal. So when users connect to our network guests via Wi-Fi or via wired, we're going to be able to present them with the ICE portal, and of course they're going to get authenticated in there via a username and password. And we can send those credentials to the guests via email, via SMS, or of course printed on a piece of paper. And also ICE has support for BIOD. Now what BIOD means is that it facilitates the use of personal devices for work. So what this means is that, like back in the days when you got hired to a company, it means that they would give you a laptop or a phone, whatever that belongs to the company, so you can perform your work. But for a couple of years ago, when this term was invented and the need came in there, because we want to let users use what they feel comfortable with. So if our internal company policy was to use Linux devices, it doesn't make sense to hire people just based on the fact that do they know Linux or not, so they're going to be able to use a basic computer. So instead of that, we want to just, let our employers be happy so they can use in the network whatever devices they feel comfortable with, like an Android smartphone, an iPhone smartphone, a Windows smartphone, whatever they feel comfortable with, whatever they know how to use. The same thing for laptops. Some users may prefer Windows, some users may prefer Mac, other users may prefer Linux. So because we open ourselves to this challenge in here, then we have to basically allow the users to bring their own devices to the network and use them as corporate assets to get access to the network to be able to perform their day-to-day job. So ICE provides support for this BYOD topic, which means we're going to have a dedicated portal just for BYOD enrollment, where employees can get in that portal, authenticate with let's say with enterprise credentials, and self-enroll their personal devices to show up like corporate-owned devices. So what's going to happen when a user brings in its laptop in the company? Because, for example, as we said before, in general enterprise assets, you want to authenticate them via .1x, not via MAB, because MAB is not secure. So what this means is that if we let those users use their own devices as corporate devices, it means that we would want those devices to use .1x as authentication, not MAB. But then the challenge is that it's not scalable to, tell those users, okay, bring those laptops to the headquarters so we can configure the supplicant, the .1x supplicant. It's not scalable. So that's why what ICE does with the BYOD support is that when the users are gonna authenticate in the web portal of ICE is gonna push a .1xe profile to the end user system. And then when the end user connects again to the network with its personal device, it's going to get authenticated via .1x, not via MAB. So BYOD support is simple, allows users to bring their own devices to be used as corporate devices to perform their day-to-day job. But to behave like a corporate device, we need that device to get authenticated via .1x. And ICE allows that when the user authenticates in the portal of ICE is going to push down to that user's device a 802.1x profile pre-configured on ICE, so that when the user connects again, he's going to get authenticated via .1x, and of course authorized accordingly and given access in the network to whatever they need to get to access in the network.